Hey everybody, it's Larry with another Edge update. So today we're going to talk about our 3D printers and why we're going with 3D printers, why we're using them here. The reason why we bought them is because we're in the process of seamlessly converting our castings from China to a foundry up in Michigan, and the only way to do that is to make our own patterns. So now we could send them out and have a pattern maker make them, but I've done injection molding for 21 years, so I understand the concept of doing molds. The owner of the casting company told me that I could just make them on my own, or I could pay somebody, like 50 grand to make them for us. So I opted to do it my way. And what we did is we picked up these 3D printers. Now, these 3D printers, we picked them up specifically for the reasons you read about 3D printers being useful, right? I don't have to have a machinist here to make these objects. I can just hit click and print and walk away for 15 hours and come back. Now, it took some time to adjust our settings and all of that here, but we're getting very good solid prints out of the machines. So it's exactly that. Now we get to click print and come back 18 hours later and we've got a mold half. In the case of this here, we've got two pieces. This will be a 2-up mold, and this is for the slide on our head. This connects to from the spindle box to the Z-axis column. And as you see here, it's got all the features deleted. Some of the things that we had to do is we had to add draft to the sides of it so that they could pull it out of the sand really easily. We've also removed all features. There's no holes, there's no markings other than the base casting. And the reason for that is to mold those in would take a lot of time to do, whereas to machine them in after they're molded is no time at all. So what we'll do is we'll send this off. We still have a lot of work to do. As you can see, there's a lot of striation. You can hear it. So there's a lot of striation pattern there from the 3D printer. And what we need to do is we need to surface the whole thing, sand it down, make it really smooth, paint it with some polyurethane, and then we can send it up to the casting company. And they're going to do a couple test prints for us, or a couple prints. They're going to do a couple test castings for us. They'll send them back down, and while we're finishing up the rest of our molds, then we'll put our test prints on the mill, and we'll be testing out all of our formulas. We'll be making sure that our recipes for the CNC machining process is right, as well as being able to check the accuracy and making sure that our setups are going to be fine. And the goal for this is to seamlessly transition from the machines we're using now, the castings we're using now, into the ones that we're getting from Michigan, and you'll never notice the difference. For the most part, the machines are going to remain exactly the same. There are some cosmetic differences, but other than that, they're going to remain exactly the same. Same capabilities, same performance. It's just at this point, once we get the castings made, literally 95% of the entire machine is made in Michigan, Indiana, and Ohio. We source all of our components except for electric motors in those 3 states. We manufacture and design our own circuit boards. We manufacture and design our own harnesses to go in between the motors and the circuit boards. So everything that we can, we're bringing in-house as much as possible. The sheet metal is made by one of our sister companies, AccuBurn, out in Attica, and they bring it in. We get it powder coated locally. The castings will go out. Those will be powder coated locally. Everything will be made here, and it's big for us to try to help, with the manufacturing in the United States. Plus, it gives us all jobs, so you can't complain about that, right? So this is a simple pattern. This one here would be the pattern itself is going to be attached to a board. And that board you'd set upside down and put your casting plate on the outside of it, your cope or your drag on the outside of it, and you'd fill it with sand, and then you'd flip it over and pull the core out, right? And then wherever the hollow is, that's where the steel's going to flow in. So this one's a really simple mold. On the course of probably the most complicated mold that we've got 2 molds that have to have inserts. This is the first one. So on our mill, this is the other part to the one that I just showed you. This is the spindle box. So if you can imagine, these 2 pieces go together and they'll be separated by a plate. It's what they call making a match plate. So you'd have 2 patterns on each side, and that's so you could do the sand casting or the sand pours at the same time. Now what we've got here is these cylinders on the top. This is where our insert's going to go, and that insert will be modeled so that you can remove it but leave in the rough details of where our bearing presses are going to go and where the bearing races are going to go. And then we'll take that and we'll finish machine them with a boring bar or a boring tool in the mill when we go to mill them. A couple of things that I'd like to point out is on all the surfaces we add several degrees of draft on them, so you can see there's a slight angle on all the surfaces except for the top draw surface. This surface is great. The cylindrical surface is fine because it'll pull nice and clean from the molds. We just have to clean it up with a little bit of body filler, and then once again we'll hit it up with some epoxy and some urethane, and that'll make the whole mold ready to go. So each one of these takes a bit of time to do it, but I don't have to shut down a CNC machine. I don't have to shut down production in order to make these, which up until now, that's been the bottleneck. We should have done these about 4 months ago. The problem was we just couldn't come up with how to do it. Jacob and I talked about making them by hand, doing wood mock-ups of them, but that involves a lot of handwork, a lot of time where we're being pulled off of production and pulled off of other things. We also had a very large trade show that just passed. IMTS was our best trade show we've ever had. Some of the relationships that we made there are relationships we'll have for the next 20, 30 years in business. And so it was very important for us to put on a good show there and to show people our machines and the capabilities of our machines. Now by being able to make the castings and using these 3D printers, we're going to be able to do, by the turn of the year, everything will be made here in the United States except for the electric motors. And we're trying to source those too. If you know of a motor supplier, hit me up in the bottom of the comments section so that I can go and check them out, because we are interested in using everything made in the United States. As of now, all of the tooling that we use, all of the nuts, bolts, fasteners, everything are sourced from United States suppliers, and not only just the supplier, but the companies that make them. Sometimes it costs a little bit extra, but I want to support United States business, and that's the best way to do it. As you can kind of see, our 3D printers are rather large. We got 2 of them because it is such a long process to do. As you can see, this one over here, it's printing, and it takes a bit of time to do the prints. So we want to make sure that we're maximizing our time, because we only have 3 months to get these finished, sent out, have them test, bring them back in, perfect our process, get all the machines put together, and start shipping seamlessly in the new year. So, having 2 of these is fantastic. Online, they tell us that these are one of the best ones that are out there. So that's why we went and got this specific model for the size. And so far we're having fantastic luck with them, and I'm getting to enjoy 3D printers a little bit better, which is, if you know me at all, that's a huge change. So with that, I think I'm going to go ahead and call it another Edge update. Don't forget to click like and subscribe below, and click that alarm button so you can get notifications of any new videos that we've got coming out. Keep an eye out for our new training series that's going to start coming out. Weekly videos on CAD, CAM, and machining, using specifically our machines to do the process. And I'll see you on the next video.